and today I'm going to show you how to improve our previously built 4D Fuse temple scene demo in HDRP. We start right there where we left off in our first installment with the recreated demo scene. The first thing we want to do is to import HDRP into our project. We're going to do this the same way we did with LWRP in our last installment. Let's go to Windows, to the Package Manager. Make sure that you have Show Preview Packages enabled. And now search for High Definition Render Pipeline. So we're going to install this High Definition Render Pipeline into our project. So, now that the High Definition Render Pipeline is installed, the next thing we need to do is go to our project settings to Graphics and assign a new render pipeline asset. For that we need to create a new render pipeline asset in our projects folder. So let's go to Project Assets and let's create a new Create Rendering High Definition Render Pipeline Asset. I'm going to call it HDRP Asset. Now let's assign this HDRP asset to our scriptable render pipeline as setting. And upon assignment, everything is hot pink again. That's because our current shaders do not work with the HDRP render pipeline. So let's go back to Edit and let's go to Render Pipeline. And now upgrade project materials to high definition materials. Press Proceed. As with the LWRP render pipeline, you have to update all of the materials in your project manually. Now that all of the materials from my temple have been updated to HDRP, I also quickly rebaked the scene so that all of the false information from before is now gone. Now I'm going to update the material on our sequence to be compatible with HDRP since the standard shader is not compatible. So let's go to our sequence mesh 4DS and yet select a new shader. HDRP Lit Shader. Let's quickly change the preview frames to fix the broken textures. And let's also set the smoothness all the way to 0. Alright, that's it for now. Before I start setting up the scene for baking light maps, I have to explain some things and facts about Unity and HDRP. The HDRP physics-based lighting model no longer has ambient lighting. Instead, you could use HDRP volumes overrider of a skybox gradient sky, HDR sky, or procedural sky lighting. But since we haven't inboxed scenes, those solutions would not help us. The biggest problem is that without ambient light, all vertices that are not directly or indirectly affected by lights appear completely pitch black. In order to change that, we're going to use a trick. We're going to use baked lights to simulate our ambient light in HDRP. In order to affect our sequence, which is not static and thereby is not affected by baked lights, we need to use a light probe group. But a light probe group loses its information when it's moved. So, to get around this problem, I'm simply going to select our full temple and move it up a bit. I'm basically going to bake the ambient light for our temple and some of the couple lights that are not affected by a real-time light and the ambient light for the sequence independently, and in the end merge them back together by dragging the temple down. So let's start by setting up some baked lights in our temple. Let's go into our hierarchy and create a new point light. I'm going to call this Ambient Dome. I'm also going to make the Ambient Dome point light as a child of the temple, so that when I later drag it around, it wouldn't accidentally change position Let's place this ambient dome light into the top of our couple. Right here. Let's also create a second point light and call it ambient temple. Let's put this ambient temple point light somewhere between the floor and our ambient dome light. Right here. Okay. Down at our sequence, I'm first going to disable our spotlight since it's still in the same position. So we do not have any fake lighting on it for the moment. I'm also going to create a new light probe group. So let's go into our hierarchy, lights, and select a new light probe group. Let's put this light probe group right around our sequence. I'm going to set it as a child. And I'm going to set our light probes up somewhere around like this. Now I also need a new point light. So let's go into our hierarchy and add a new point light. Let's call it ambient sequence. I'm going to make this one a child of my light probe group. And I'm going to set it into the center between our light probes. Perfect. Now let's quickly go back to the temple and set up our baked light. So let's select our ambient temple and set the mode to baked. Let's select our ambient dome and also set the mode to baked. Let's select our point light down here, the ambient sequence, and also set our mode to baked. Since it is impossible to predict the outcome of our baking process, I'm going to leave the rest of the options as default. During the trial and error run to find the perfect lighting conditions for our baked ambient light maps, I'm going to lower all of the light map settings so that the baking process is faster, and I'm going to higher it for the final bake. So let's set our direct sample down to 20, our indirect samples down to 250, our environment samples are also down to 250. Let's set our bounces down to 2, set our indirect filter radius down to 1. Let's set our light map resolution down to 15 and our light map size down to 1024. We will leave the light map parameters at default medium. Let us start generating the light map and redo the procedure until we have a good looking ambient lighting condition. Now that the baking process is complete, I came to the decision that for this particular scene, the best ambient lighting results are for the ambient sequence to have an intensity of 50, for the ambient dome to have an intensity of 80, and for the ambient temple to have an intensity of 65. Next, let us put our scene back together. So let me put the temple back to its original place. As you may have noticed, the characters are rather bright in comparison to their surroundings. That was intentional, since when I add my real-time light from the top, the ground will be in direct contact. But parts of the sequence who are not in direct contact are completely dependent on our light probe group ambient light settings. So let us bring our spotlight back into the scene and let's position it somewhere above the couple so it shines directly down into our scene. Higher the intensity to 5400, and let's also enable our shadow map so that we have shadows on the ground. Let us higher the shadow resolution to 2048 so that we have a very sharp and intensive shadow on our ground. Let us add an HDRP volume effect. Just like in the LWRP video, I also want to add some fog into the scene. But I don't want to add simple fog, but rather volumetric fog. So let us go to our HDRP volume. Let us add a new overrider and let's select volumetric fog. Let us also select the quality options for the volumetric fog. Volumetric fog quality. Let us enable all of those options. To import the fog into our scene, we need to enable it through our visual environment. So let us go to visual environment, fog, and select our fog type to be volumetric fog. Now the volumetric fog is part of our scene, but not a lot has changed in our scene, as you can see. The reason for that is that our base fog distance also decides about the intensity of our fog, and at the moment it is very thin. So let us lower this number down to around about 10. Now we have a very strong fog. As you can see, our real-time light has created a misty environment into our scene. Now that our light maps have been baked, and the bare bone of our lighting scene and special fog effect are integrated, it is time to give some finishing touches on the lighting. To start, we're going to go to the HDRP volume, and we want to add a new overrider effect, the Lighting Indirect Lighting Controller. So let us add it and activate its options. The Indirect Lighting Controller can brighten up the scene's light maps and effect of our light probes, so that we have a little bit more contrast in our scene. Let's set the indirect diffuse intensity to 5. Now that our indirect lighting controller has brightened the scene, I also want to add a second real-time point light into the scene in order to brighten up the environment without losing the contrast of our shadows on the ground. To do that, I'm going to use the ambient temples light that we have already created, and I'm going to call it real-time temple. I do not want it to have an effect on our already created volumetric fog, because if we deactivate our gizmos, you can see that the real-time point light creating a spherical effect in our volumetric fog. We do not want this spherical effect around it. So let us select our real-time temple point light and let us deactivate its volumetric functions. Now that the volumetric functions are deactivated, I want to activate the shadow map so that we can draw a clear contrast shadow on the ground. And I'm also going to higher the resolution to 2048. Now that we have made sure that volumetrics are disabled and the shadow map is enabled, I'm also going to change its intensity to brighten up the mood a bit. Let's say to 600. As you can see, using this little real temple time point light has also created more or less a penumbran effect from our shadows onto our ground, adding a little bit more immersion to our scene. Now that all of our elements are in place, we can look at our final results. So let us save this scene and press the play button. I hope that this short tutorial was helpful to get you started. For further questions about our plugin or our holographic capturing technology HoloSys, please contact us on our website 4dfuse.com.